So I'm going to record this explanation of this question, so it'll be available to you later. It says, write the slope-intercept form equation of the line that passes through negative 3, 6 and negative 4, 8. So first, we need to understand what they mean by slope-intercept form, right? And what is slope-intercept form? That's y equals mx plus b. So in order for us to write the equation in slope-intercept form, you need two things. You need an m, and you also need a b. If you knew the m value and if you knew the b value, then you'd be able to write it in y equals mx plus b. That's simple. But they don't give you a slope. They don't give you a y-intercept. They actually give you two coordinates, right? Bless you. So they tell you that your line passes through these 2 points. Now, one option is to actually graph it on graph paper, negative 3, 6, put a dot right there, negative 4, 8, put a dot right there. Then you could see how much you rise and run and get your slope that way. But we're going to stick with algebra here since we don't have graph paper in front of us. We are going to use the slope formula, and the slope formula is m equals y2 minus y1 over x2 minus x1. And we already know that when we use this formula, it's a great idea to leave it with blank spots, put the division and the subtractions with blank spots, and then identify your x and your y values. And of course, this is x from our first point, that's negative 3, y from our first point is 6, x from our second point is negative 4, and y from our second point is 8. So when we plug in our values, y2 is 8, y1 is 6, x2 is negative 4, x1 is negative 3. Sure, why not? So we need to change those minuses to plus, and then we need to simplify this fraction. So our slope is 8 minus 6 is 2, and negative 4 plus 3 is negative 1. So our slope is technically negative 2 over 1. It's a drop of 2 and run of 1 to the right. Or you could just say that it's negative 2. And I would say negative 2 for the sake of this problem, all right? So at this point, we have the 2 points that they gave us, and we have a slope that we just found. So if we know a point and a slope, it may be optimal to go with point-slope form, right? Which is y minus y1 equals m parenthesis x minus x1. And whenever we use point-slope form, I suggest rewriting it with what you see in black right here and leave everything else blank so you could plug in your values. Similar to what we do in the slope formula, we rewrite it but with blank spots. So we're going to rewrite this y minus blank spot equals blank spot parenthesis x minus blank spot, all right? So we're going to plug in our y1 value right here. And where are we going to get that from? Well, y1 up here says that it's 6. That's the y value from our first point. So we're going to plug in a 6 right in that blank spot. Then we have the m value, which of course we found out was negative 2. So our m value is negative 2. And then our x1 value, where's that going to come from? It's going to come from that first x value of the first point, which is negative 3. So you put a negative 3 right there. And you could clearly see that the minus changes to plus. Okay? So here is our point-slope form equation. Y minus 6 equals negative 2 parenthesis x plus 3. And are we done? Well, if they asked us to write any equation, yeah, we'd be done. This is an equation in point-slope form. However, they didn't say any equation. They specifically said write the slope-intercept form equation, which is y equals mx plus b. Okay? So we need to still modify this point-slope form to this slope-intercept form. Again, form is the way it's organized, and we just need to organize this equation. We need to change the way it looks so it looks like this, right? So what are the two details about y equals mx plus b when you compare it to point-slope? Point-slope has parentheses, and y equals mx plus b does not have parentheses. Point-slope form has y minus y1, in this case y minus 6, and slope-intercept form just has y by itself. So we're going to have to get rid of the parentheses by distributing, and we're also going to have to get rid of that minus 6 by adding 6. So with that said, I need to get rid of the parentheses. And in order to do that, you'd have to distribute the -2 into the parentheses. So we're going to go -2 times x, that's -2x. -2 times 3, that's -6. We're going to bring down the equal sign, bring down the -6, bring down the y. And then from there, we want to get the y by itself. So we're going to have to add 6, and in this case, we end up with y equals -2x plus 0. You don't really need to put the plus 0. You could put it if you want, but I'm not going to leave it there. I'm just going to leave it as y equals -2x. And this is in slope-intercept form. What does this mean? That it crosses the y-axis at 0, and from that point, it goes down 2 over 1. Do we understand how to do this?
Yes.
Okay, one person gets it. Okay, hopefully everybody gets it. Do we have to go with point-slope form? The answer is no. You don't have to go with point-slope form. Okay, you could stick completely with slope-intercept. Okay, it said in the beginning, write the slope-intercept form of the equation. Okay, so they give you 2 points, and we found the slope using the slope formula. There's the m. We still need the b. If we had the b, which in this case we already know that the b is going to be what? What number is added or subtracted over here? 0, right? So we already know the b is going to end up being 0. But let's pretend that we didn't want to go with this route. There's many roads to the same place in math. That's the beauty about it. So right here we have the m, we need the b. But let's say we don't want to go with point-slope form. I mean, I think this is the best way to go with point-slope form. You have a slope, you have some points, go with point-slope form. But let's say you wanted to go just with slope-intercept. So if you wanted to go just with slope-intercept, you would rewrite your slope-intercept form equation, y equals mx plus b. And you have to recognize that if you want to find something, in this case the b value, you take the information that they give you, in this case a point, and the slope that you just found. You could plug in the m value of -2 into the m. Now if you don't like this alternative method, go ahead and stick with the original method, which I believe is best. But anyways, I want to take this m value of -2 and I want to put it right there where the m is at. So that's a -2 right there. And then I need to multiply it. I need to multiply it by x. But what is x? Well, technically you have 2 x values. I want to go with the first one. That first x value is -3. So I could put multiplication of -3 right there where the x was at. And then bring down the equal sign. And the y value, since I used this x value, I'm going to use this y value of 6 and plug it right there where the y is at, 6. And of course, we don't know b, so we're going to leave it plus b. The whole purpose of this, of plugging in m and plugging in x and y, plugging in m, plugging in x and y, is to be able to get an equation that we could solve for b. Because once we know the b, and we already have the m, we'll be able to write it in y equals mx plus b form. So doing the math here, -2 times -3, that's +6. You still have plus b, you still have the equal sign, you still have 6. So you want to solve for b, you want to get b by itself, get rid of this +6 by subtracting 6 and subtracting 6, and then you'll clearly see that that cancels out, and this cancels out, which means 0 equals b, which means b equals 0. So we now do have the m, which was -2, and the b, which is 0. And now that we have the m and the b, we could write it as y equals mx plus b, which is the same exact equation as what we did over here, right? Just done in a different manner, okay? So I prefer to go with the information they give me and use the best form with that information. So they gave me 2 points, which means I was able to find the slope. And once I have a slope and some points, I go straight to point-slope form. Why? Because I have a point and I have a slope, or I have points and I have a slope. So I go straight to point-slope form, and then I manipulate that to whichever form they want me to do it in. But you could, if you really wanted to, just stick with y equals mx plus b. How? By taking your 2 points, finding the m value, and then using one of those points as an x and a y value, I'm plugging it into the x, plugging it into the y, and plugging in your m. That way you can have an equation that's solvable for b. And then once you solve for b, you'll have the m and the b, and you'll be able to write your y equals mx plus b equation. So when you take a look at this work, it looks like it's a ton of work, but in reality, I did the same problem 2 times. So I, like I said, would prefer to go with point-slope form. I have 2 points, I find my slope. Once I have my slope and points, then I would go with point-slope form. This is the work, that's it. So in reality, you wouldn't see this work over here if you went with this route. But if you wanted to stick with slope-intercept form, then after you find your slope being -2, then you could plug in the m, plug in the x and the y from one point, x, y, plug in m, solve for b, and then you could write your y equals mx plus b equation. So again, one or the other, whatever you feel more comfortable with, that's what you should do. So if we read this carefully, they say write the slope-intercept form equation. So again, that's going to be y equals mx plus b, y equals mx plus b. That's what slope-intercept form is. They want you to write the slope-intercept form equation of the line that has the slope of 3 and an x-intercept of -4. So we know that if they give us the m value and they give us the b value, then it's really easy to just write it in slope-intercept form. Do they give us the m value? Yes or no? Yes. What is the slope value? 3. So they give you the slope value. We still need the b value, okay? Do they give us a y-intercept? No, they don't. They give us an x-intercept. That's not the same thing as a y-intercept, all right? So we really need to think about what information they're actually giving us. They are giving us a slope for sure, and they're giving us an x-intercept, which is an actual location on the xy plane. So if you were to think about it, here's your x-axis, your y-axis. They're telling us that it has an x-intercept of -4. So on the x-axis at -1, 2, 3, 4, your line's going to cross right there. So once again, what are they giving us? They're giving us a slope value of 3, and they're giving us, indirectly, they're giving us a point. The location of this red dot is what? -4, 0. So they're giving us a point and a slope. So even if they want us to write it in slope-intercept form, they're giving us a point, -4, 0, and a slope. So I would go with point-slope form. Point-slope form. And what is point-slope form? It's y minus y1 equals m parenthesis x minus x1. And when we use it, I recommend going with blank spots, right? Y minus y1 equals m parenthesis x minus x1 with blank spots. And then we plug in the m value that they gave us, which is 3. Then we plug in the point that they gave us indirectly, because they told us that it has an x-intercept of -4. They're telling us our lines are going to cross right through here. So that means that that is a point. So the x value is -4, the y value is 0. So the y1 is the y1 value of 0. So you put 0 right here. And the x1 value is -4. So you put a -4 right in there. So your point slope form equation, change that to minus the plus plus, is right here. Y minus 0 equals 3 parentheses x plus 4. However, they are not asking for point slope. They're asking for slope intercept. So once again, slope intercept, it has y by itself. And technically right here, this is y by itself, because y take away 0 is just y. Now, if you had a y minus 5, you would get rid of the -5 by going +5 and +5. But it's y minus 0, so you don't need to write y minus 0. That's just regular y. And then you could get rid of these parentheses right here by distributing the 3 to both terms. So if you distribute that 3 times x, that's 3x. 3 times +4, that's +12. And believe it or not, you're done. That's your slope-intercept form equation, y equals 3x plus 12. That's my slope-intercept form equation of the line that has the slope 3. It does have the slope 3. And it does have an x-intercept of -4, right? So I hope this helps. So on this question, it says, write the standard form equation. And right off the bat, you need to remember that standard form is capital AX plus capital BY equals capital C, where A, B, and C are just numbers. No fractions, no decimals. Obviously, you want x's and y's on the left side and a number by itself on the right side of that equal sign. So whenever they ask for standard form, don't even worry about standard form right now. Right now, just do whatever you can when they give you 2 points. And what is the only thing you could do when they give you 2 points? You could find what? Slope. That's right. You could find slope with the slope formula with m equals y2 minus y1 over x2 minus x1. And whenever we use this formula, I always recommend to do the division sign first, the subtractions, and then plug in your values. But first, label your values. Each coordinate is an x and a y value. So put x and y on each of them. Your first point, you're going to label it x1, y1, and your second point, you're going to label it x2, y2. That way, you could clearly see what you're going to plug in on the y2 spot right here, which happens to be 6. The y1 spot is 2, and on the bottom, you have x2 on the bottom left, which is -9, and bottom right is x1, which is -3. So the minus needs to change to plus, and then you simply do the math. 6 take away 2 is 4 up on top. -9 plus 3 is -6 on the bottom. So our slope, we always say that we want the negative to go up on top or in the middle. And we always want to reduce the fraction as much as possible. So if you reduce by 2, it'll be a -2 over 3. That is your m value. That is your slope. Okay. So what do we have here? We have a slope and we have some points. So because I now have a slope and some points, I'm going to go with point-slope form, which is y minus y1 equals m parenthesis x minus x1. And whenever I use this form and whenever you use this form, I recommend rewriting it with what you see written in black and leave everything else blank. That way you could easily plug in your values. So again, rewrite it y minus y1 equals m parenthesis x minus x1. And as you can see, as I was saying that, I didn't actually write the y1 or the m or the x1. Why? Because I want to get those values. The m is -2/3, so I'm going to put that right in there, -2/3. And then I'm going to get the y1 value from up here, y1. This is a y value also, but since we said y1 and we labeled this y1, that's why I'm picking this y value of 2. Put that 2 right there. And the x1 value is -3. Put the x1 value of -3 right there. And change the minus to plus. And there is your point-slope form equation. So if they did say, write it in point-slope form, I would be done. This would be it. Y minus 2 equals -2/3 times x plus 3. However, it doesn't say that. It says write it in standard form. Okay. So standard form does not have parentheses. Obviously, it's capital AX plus capital BY equals capital C. So if you ever want to get rid of parentheses, you have to distribute, right? Now, some people don't like distributing because it's a fraction. So you could get rid of the fraction by multiplying by 3. That would cancel it out. That way you only have to distribute a -2. But you'd also have to multiply this -2 times 3 and the y times 3. But you don't multiply the inside values by 3 because whatever you do to the outside guy, it's like if you did it to the inside guys because of distributive property. But in this case, distributing the fraction shouldn't be that bad. Let me actually zoom in a bit. So we could distribute the fraction, but you know what? I'm going to get rid of the fraction because standard form, you don't want fractions anyway. Okay, so I'm going to actually multiply everything by the denominator of 3. So times 3, that way the 3 cancels with the 3. But I also need to multiply the 2 times 3 and the y times 3. Now, again, you might be thinking, why don't you multiply that by 3 and that by 3? Because whatever I do to this outside value, it's like doing it to the inside values because of the distributive property that's going to happen anyway. So I am not going to multiply the inside of the parentheses by that 3, just everything on the outside. So my new equation without fractions will be 3y minus 6 equals negative 2 parenthesis x plus 3. And now it's easy to distribute the negative 2. You could have distributed the negative 2/3, but I think it's a little easier to get rid of the fraction by multiplying everything by 3. So now we're going to distribute that negative 2. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. We have the equal sign, bring down the 3y, bring down the minus 6. There's your new equation. They do want it in standard form, which means you want your numbers to the right side and the x's and y's on the left side. So I'm going to get rid of the minus 6 by adding 6 and adding 6, which happens to cancel out. And then I want to rewrite this thing, 3y equals negative 2x, and there's no more numbers without variables. But I still need to get it into standard form, which means I need to move the negative 2x to the other side by adding 2x and adding 2x. Now you can't really add 3y and 2x, so we're just going to rewrite it. A positive 2x plus 3y equals nothing on the right side. So this is your standard form equation. 2x plus 3y equals 0. Okay. Does that make sense? So this does look like a lot of work. I mean, it is a lot of work. But I hope you guys understand this. Let's try a couple more. Check this out. These two are so easy that you're going to like them. Okay. It doesn't say in any form. It says write an equation. Could be in slope-intercept form, point-slope form, any form you want, right? And they give you 2 points. And of course, when they give you 2 points, what do? Find the slope using the slope formula. Slope formula being y2 minus y1 over x2 minus x1. And of course, always rewrite it with blank spots and label your coordinates x1, y1, x2, y2. Plug in your values, negative 2 right there, positive 4 right there, negative 8 right there, and a negative 8 over here. The minus minus changes to plus plus, and you end up with a negative 6 over 0. When 0's underneath, what is your slope? Undefined, okay? So, undefined. What the heck does that mean? What does undefined mean? That means that your line is so steep that it's undefined. It's perfectly vertical. Does that make sense? Now, let's say you're like confused. You're like, well, I forgot what undefined means. Okay, so look at your points and recognize what they are. They're locations on an XY plane. So where would negative 8, 4 be at? Negative 1, 2, 3, 4, 5, 6, 7, 8, and then positive 1, 2, 3, 4. That would be that dot right there. Más o menos, right? Rough sketch. And then the other point, negative 8, negative 2. So negative 8 and negative 2 would be down here. Put a dot right there. What kind of line do I have here? That's a perfectly vertical line running up and down, right? That has an undefined slope. So when it's undefined, then you have a perfectly vertical line. And we have to remember what we learned in the past, that a vertical line, what kind of equation is that? It's x equals that value that it crosses the x-axis at. So this equation, this blue line, this vertical line has the equation x equals negative 8. That's your equation of this blue vertical line, okay? And the other one, if you haven't guessed it already, when you do slope formula, you're going to end up with y2, which is 3, y1, which is 3, over x2, which is 1, x1, which is 5. You're going to end up with 0 over negative 4, which means that your slope is 0, right? Now, what does that mean? If your slope is 0, what does that line look like? A straight line, totally flat, horizontal, right? And if you're still confused, you could think about the visual of this. 5, 3, 5 on the x, 1, 2, 3, 4, 5, 3 on the y, 1, 1, 2, 3. So there's 5, 3. And where's 1, 3 at? 1, 3 is right there. So obviously, this is a totally flat line crossing the y-axis at 3. So your equation of this blue line with slope 0 would be y equals 3.